Hello, everyone. Nice to see you on this ACE course. So in this module, we're going to see together one way of organizing your data and your code so as to produce figures and tables for a research project. So let me share my screen. So for this project, we're going to use as a basis, as an example, the article Extended Print Positioning Duration for COVID-19 Related ARDS. So in this folder, you see that you have a folder with the data. So a name here, random data, because obviously we didn't use the real data of the article, but mock data, which we randomly regenerated. So in this random data folder, you've got a random demographics. So if we open this, you see that you'll have a column named Guppy. So that's just the name for the anonymized number for the patient, whether the patient is included or no, the age of the patient randomly generated, the sex, good. We've got another file, which is the pressure injuries file. So that's very easy, the number of the patient and whether this patient had a pressure injury or not. Then we have a third file, which is prone positioning. So in this file, prone positioning, we have, again, the number of the patients. We have for each prone positioning session, so this patient, patient number 2, for example, here had 3 prone positioning sessions. And for each session, we have the FiO2 before the prone positioning session, the tidal ventilation before the prone positioning session, the PEEP, plateau pressure, and the blood gases results, pH, PaCO2, PaO2. And we have those same values during the prone positioning sessions. And then before being turned back on the supine position, and then after being turned back on the supine position. And here that's more of a polishing file. So here in this list 1, table 1, you have sex, the same name, and then you say how you want it to be printed out on your final table. And you'll see that this is going to be a main driver of this organization. You've got to output your tables and your figures exactly in the way they are going to be printed out in your article. There must be no cross-processing on Paint or PowerPoint or whatever you want. That's going to save you thousands of hours and errors. So this is for the data file. Then we have another file here, and that's the code. So in the code folder, and you have 4 main scripts. So a script is just an R file. You have a script for downloading the packages which you need for your project. So if I open this one here, you see that this is the list of the packages I'm using for this given project. And I just use this little package pacman here that allows me to use this function pload, which will then load all the packages at once. It avoids me from like copy pasting library 1,000 times. Good. And then we have 3 scripts here. So we have one script with all the functions which allow for the pre-processing of data. So we have a function to upload the pressure injury file, a data for uploading the demographic file, and a function for uploading the prone positioning file. And you see that those functions can be very simple. Here it's a simple read XLSX, but for the demographics, for example, it can be much more complicated, and you have sometimes to transform the type of the variables. You have sometimes to recode them, and you have sometimes to compute new variables out of the one you've manually entered in your Excel file. For example, the BMI out of the weight and the height, or the theoretic optimal weight for computing the tidal volume, for example, here. So once your data are uploaded and pre-processed and clean, they are ready to be analyzed, and all the functions used to analyze the data are recorded and stored in this script here, functions analyze. Those are all the functions I'm using to go from data frame with my curated data to outputting my tables. And finally, you have the same thing here, functions visualization, which are all the functions that allows me to go from the curated data to the production, the output of figures. Then we have a very interesting file here. This is an R project file. So if I open it, the only thing it does is that if you get the working directory, you'll see that it starts where your folder is. So if I go back here, my Finder, where am I here? So you see that I'm in Macintosh Utilisateur OneDrive. And so that's where we start in this session. Okay, let me just close this one and be with this one. Okay, so now that's for the R project. I'll show you the final output of this project. And for this, I'm going to use a notebook. A notebook in R is something that allows you to have both code and written information. Hello, I am Water, for example. All this organization is meant to allow you to run this. So I'm going to run this file here. So run everything, run all. So we have the table 1 here. We have how the patient were taken in charge of. And we have here the risk factors for pressure injuries, the only figures of this article. So this is the objective. You've got data in Excel files, and that's the output you want. You just click on one button, make. And you don't have to rethink how your pipeline work, how you organize everything, what functions you have to start first and then do the second one and then output this figure and then this table, etc. You just click on a button and then everything is outputted at the same time and you know that everything is up to date. That's the whole point of this organization. How do we do that? Well, we use one file. This file is called targets.r. And targets.r is like a map. It's a map that says, take this data that are located here, use this function and output this results. It doesn't do anything. It's just a set of instructions. It's like a recipe which you write depending on your project. So let's open it. So targets.r, I start by uploading all the functions which I need. Where is this package here? So here is a very powerful tool to use within an R project. So you remember that your current working directory is automatically set, where here allows you to write a relative path. If I run it here, you see that the here function will transform it into an absolute path using your current working directory of your local computer, which means that if you have to send your whole project to another people, or if you're working on several different projects at the same time open on your computer, you don't have to change the current working directory. Everything will be automatical, and that's going to save you a huge amount of time. So coming back on the targets file, so you first upload all your functions and all your packages with this, and then you just have a list. So in this list, you've got two types of objects. You've got, so a tar target is like an object. So this tar target here is a pointer. It says, okay, you have some data, which we're going to call pressure injuries file, which is located here. And you just tell targets that it's a file. Okay. And then you tell, okay, so using this data here that we've just defined, please apply these functions. And you're going to obtain something that is going to be called raw pressure injury data frame. And you do that for obviously all your files. You have several intermediate data frames that you're going to use to produce your final tables and figures. And this isn't doing anything. This is just saying this is how data frames are going from row to the final figures. If you want to output the results, you have to open a notebook to upload the targets package and to use this function, tar make. Tar make is going to do everything that's written in your targets.r file. It's not going to show it to you. It's not going to output it to you, but it's going to do it, and that the results are going to be stored on your computer. Now, if you want to see the results for each target here, you can upload it locally on your RStudio. And for this, you use the tar read function. Okay. So this here, for example, if I put it here, the table 1, so you see that it uploads it on your computer, but because it's not very nice to use it, you can put it into an object, which I've called table 1 because it was the table 1. Okay. And the parentheses here it's just a way to tell I to print the results. So like that, I can run like the whole cell, and all 3 tables and the figures are going to be automatically printed out. Okay, so the last thing I wanted to show you is that a nice thing with the targets package is that it allows you to visualize your whole workflow. And you do this, use this function, tar this network. Hop. And you see that here you've got your original file. So your demographic file, your prone positioning file, and your pressure injuries file. And so if you look at, for example, table 1, it shows you the whole workflow from, it tells you, okay, so table 1 is just a join table between the table 1 of the final included cohort and the table 1 of the excluded patients. And then if you look at the table 1 final cohort, it uses info table 1 to transform the row working name into the name that have to be printed out, and the demographic file. So this is a way of, like, if you forget about your project for a long time and you come back to it, you can see how it works. Another extremely powerful feature that imagine, for example, that let's say there was an error and you want to change that. So you change it in your file list dated table 1, and then, so I've saved this. If you do this again, it will, because you've got a pointer to this file, to every file which you're using, this package is going to detect automatically that you've made a change in your info table 1 file. And it's going to tell you, okay, because you've updated this one, this has impacted 2 tables, table care, so how your patients were handled, and table 1. And for example, the box plot, 3 ventilatory parameters, the figures here, has not been impacted. And so when you're going to tell your computer, please do again the recipe I've written in the targets.r file, it's going to say, well, I've checked everything, and it's going to redo only the files which have been impacted by your modification in one of the original Excel file. And in that way, you're going to be sure that everything is always up to date, not going to have versions of your data frames or anything. And secondly, it's going to save you an immense amount of time if you start with working with large size data frame. So yeah. If you want to play with this code to understand a bit more how it works together, this is available on GitHub, and the link to this GitHub is available in the written part, the comments of this ACE module. Thank you very much for your attention, and I hope this is going to be somehow useful in any of your research projects. Have an excellent day.